Welcome to another episode of Executive Sessions, where we discuss trends and developments in the industrial manufacturing space. I'm your host, Clayton Gullett, and we've got an awesome show lined up for you today. And we're going to be discussing the rise of automation. And don't worry, it's not Terminator and it's not Skynet, so it's not the end of the world. Trust me. But today we're going to be running through real-world examples of how production lines are being introduced to automation and how they're making a difference for workers out there in a good way. Don't worry, it's in a good way. But I've got two guests on today that have a wealth of knowledge and are fully submerged in this field. So let's kick it off with my first guest, Mr. John Dotson. John has 25 years of experience in the automotive industry, including 22 years at Toyota Manufacturing. Ooh. His expertise spans logistics, safety, quality, maintenance, engineering, and production. John currently leads the MiddleGround Capital Automation team. Do you put all of that on a business card? Like, how do you...
I have to use the front and the back, but
you have to use the front. That's pretty good. I would just staple another one on, at the side. I think that would...
Well, it may be. It just won't fit in a wallet. Unless you have that wallet that goes on your chain,
yeah,
then maybe it'll fit in that wallet.
You could do that. You could get a checkbook too,
Well, there you go. New ideas.
New ideas every day. Automated business card making, perhaps. Our next guest is Mr. Miles Anderson. He got his degree in electrical engineering. He's worked in the product development and the line-side production, as a line-side production engineer, then made his way to senior engineer in the vehicle performance at Toyota. Oh, all right, you guys got a little bit of a connection there. In his current role, he serves as the vice president of automation and maintenance, where he's responsible for the management of both teams. Miles, welcome to the show, man.
Thank you. Happy to be here.
I'm glad to see that I'm not the only bald guy on the show today.
Love your haircut, man.
I love yours too. Where'd you get it done at?
At home.
At home? Oh, man. That's... I cry every time. Oh, God. No, I'm just kidding. You guys ready to dive in, though?
Let's get to go.
Let's do it.
Let's boogie. All right, John, let's kick it off to you right out the gate. What is automation, and why should companies consider utilizing it?
You know what? That is a fantastic question. And it is a question that a lot of people can't answer.
That's very. I couldn't.
Yeah. When you say automation to someone, what's the first thing that pops in your mind?
Well, because I've got experience working here, I would say machines and probably taking, repetitive task, pulling people away.
But see, you're already down the rabbit hole with it. You already know this. Most people think it's robots, right?
Robots. All right.
Robots. Automation is robots, but that's not all that it is, right? So
okay.
When we talk about automation, we try to define it in the aspects of, if you have a human person that has to do a task, if we can put a machine in place to do that task, then we have automated that process, right? So a human doesn't actually have to physically do it anymore. Now, a human may have to load the equipment or unload the equipment when it's finished with raw materials and finished goods, but the machine is doing the entire process of manufacturing that part. In addition to that, automation for us, we try to get it into more of a defined area as well. So you can have automation that is fully automated, which is, it does the entire task itself, or you can have automation that's kind of manual and automated. So with collaborative robots, we can have a collaborative robot sitting right beside you. It does portions of the process, and you do the other portion of the process. So there's all kinds of different opportunities for automation. But what we found is a lot of our portfolio companies struggle to define that. So because they struggle to define that, they struggle to identify the opportunities as well, which we will talk about a little bit more later on in the show.
Miles, you got anything to add?
Yeah, I think what part of the lead off of that question also is why should more companies utilize it, right? And we've done a lot of studies, read quite a bit of articles and stuff around that, and what we're seeing is a lot of there's a shift in the U.S. market, in the labor market. They're moving away from manufacturing jobs into other industries, and that's creating a vacuum in a lot of these manufacturing facilities for, team member labor. And so that's an excellent opportunity to fill that gap, that vacuum, with automation. Another thing that we also see is onshoring or reshoring of manufacturing jobs, and that's a big portion of the demand that's coming for manufacturing positions.
Yeah, I think one of the last articles we saw was by the year 2030, half of the manufacturing processes will go unfilled because of the lack of human capital.
Oh my God! In 5 years?
5 years, and the reason being is because you have your baby boomers have retired, your Gen Xers are retiring, and the rest of the generations just do not make up that gap. And as Miles said, with the tariffs and things that are out there and more onshoring, there's going to be more jobs that are available, but just there's not enough headcount to do that. So that's the reason we have to start now and get ahead of it.
Well, that definitely makes sense. Gosh, 5 years, man.
5 years, it goes quick.
Wow. Okay. Yeah. I was going to say I'm 31, and I feel like the last 30 years have gone by really fast. Wow. Okay. Well, let's talking about onshoring and everything, and then this gap that is coming, that's forecasted to be here. How would automation solutions differ from small to large businesses?
So yeah, I think I can answer on that one. So capital is probably the largest differentiator between small and large businesses and what they can invest in automation. Large businesses can usually have the capital to invest, and maybe, for example, a large weld cell that has multiple robots and a trunnion system in there. They can really take advantage of that. But smaller businesses don't have the available capital to invest in automation, and so they might go towards something that's a small cobot welder with fixtures that are fixed in place. So that's kind of the big differentiator between the type of automation that you get with additional capital.
I gotcha. So, well, I mean, if you're listening out there and you're a small business owner, there are options for you from Mr. Miles here. And both of these guys are a wizard in what they do. So I definitely pay attention. John, you got anything to add on that?
No, I agree with Miles. I think it's got to do with the situation you're in and where you can really get that return on investment. Some small businesses, you may be able to go in and understand the true flow, be able to improve the flow, and one or two automation solutions could almost go lights out on the business, which is great. You're not as reliant on human capital. But you may be able to do that same thing with a larger business. So it's case-by-case basis. But I would say that from the smaller businesses, what you see is they're a lot more, picky and decisive on what they put in because the capital is not there as much as it is for a larger customer. But
I gotcha. Well, I know that from some of the research, I know that small businesses can also invest in things like accounting and inventory management, email marketing, and those are just a few. But I know that you guys deal more on like the actual robotic side.
Yeah, we're more of the industrial side because that's one thing is if you Google automation, what you're going to find is you're going to find a lot of automated reporting systems and things in the financial and accounting world, right? But we're mostly industrial.
Gotcha. Well, so how do companies determine whenever they're trying to automate different functions or different job roles and things of that nature? How do they know which tasks are the most suitable when it comes to bringing automation into their system?
Yeah, so when we go through some of our portfolio company facilities, first thing that we're looking for, first and foremost, is are there any unsafe processes? If there's an unsafe process, then we prioritize automating that. We want to make that process safe for our team members, and automation can fill that. The second thing that we tend to look for is the job processing around that process. Is it consistent? Is there clear standardized work? Because when you put in automation, it's executing a set of procedures, and then it's repeating that over and over and over again. And if you have a wide variety of standardized work in a single process, then it's extremely difficult to automate that. We also look at is there a large amount of scrap being generated out of a single process, because putting automation in can really improve your quality if the process is generating scrap because of team member influence. You put in a robot, it's going to move the same path every single time, and it's very consistent overall in quality. So automation can help alleviate some of your quality issues. And then probably the last one is we're looking at the product that's going through that process. Are the parts consistent in size, shape, and weight overall? Because automation is so much simpler if you have consistency across those three metrics. You can imagine, for example, if you have a part that is a very small ball bearing and a very tall, large cylinder, and both of those are going through the same type of process, designing the automation around, if it's a robot gripper, to have a stroke that can grab the cylinder is going to be very different than one that has to grab onto a small ball bearing.
So, okay, I am curious about this. As far as prioritizing, when you're running through a list of why you should bring automation into your business, is there a breakdown? Like, is safety at the top, or like how does that break down? Because I have a follow-up to that too.
Yeah. So I think if we're prioritizing, safety is top priority. We really want to prioritize getting our team members safe. We also look for what the automation is going to look like when it goes in there. How much capital is going to be spent? We evaluate with the ROI. If the ROI is significant enough benefit to automate.
So this is one of the questions that I've got for you. As far as safety goes, a process could be done, 40, 50 years the same way in a factory, and then you have a team come in, like you guys, and you look at automating a process, and you guys go, well, this is unsafe, and they go, well, we've done it like this, and there's not been any issues. What are the characteristics that you're looking for to determine if a process is safe versus if it can be improved versus being completely replaced?
John, you want to take that one?
I think, anytime that we go in looking for a process, when we're looking at it from a safety standpoint, we actually have an audit that we do. And what we're looking for is, the interaction between the team member and either the equipment they're using, and whether they can have some mistake, there's not enough guarding, there's things that's not in place to protect them from accidentally getting into the equipment. But the second thing that you're looking at is some of the ergonomics side too, because safety is not just an acute action; it can be cumulative as well, right? So over time, you're having trouble with maybe the environment it's hot. It's a hot environment, and you're just struggling with it, or you have to bend and move and twist a lot to be able to do this process. Well, all of those lend themselves very well for us to go in and say, hey, let's put some automation in here, either A, to completely replace it so that you don't have to do this process, you can do another process, or we put automation in to assist, maybe a hoist or some device that helps them do what they're doing to complete the process. And I'll give you an example. We're getting ready. We're doing a build right now, and we're getting ready in one of our factories up in Mentor, Ohio. We're doing a forging automation. Well, the guys that do that forging automation process right now, they stand in front of a forging press, and these parts come in at 900 to 1,000 degrees Fahrenheit.
Oh my God!
So they have all that heat. In addition to that, they have to move it fast because if the heat dissipates, then you can't actually forge the part out. In addition to that, they have a wand that they're having to spray graphite grease. So you've got two team members that are there all the time doing that, and it's kind of backbreaking work, and we have a high turnover in that area.
I can't imagine why.
So what we're doing is we're automating that. And it's exciting to see because, we can automate that, and then we can take those team members and move them somewhere else.
So just out of curiosity, what would be some examples of an easy fix, a low-hanging fruit, if you will?
You know what, Miles, give the information that you had about. I think it was the push rod former, right? That we used this morning.
Yeah. So, low hanging fruit when you walk through a factory is a situation where you have a team member that's in front of a single machine, and really all they're doing is loading and unloading that machine, and it's high repetition. Upwards of 2,000 parts a shift.
Oh, wow.
Excuse me, and the parts are if not the exact same part, they're very, very similar. So the example that I have for that is, up at Race Winning Brands and Trend Performance, they had a push rod former, and this is a machine that would the team member would insert a raw push rod into it. They'd press a button, and the press would come down from the top and from the sides and form the ends of this part. And then the team member would use a rake and break that part out. And that was the process, repeated over and over and over again. They had 4 of these machines, staffed, 1 per machine, and they were running it for 2 shifts. So you have this tremendous opportunity. Looking at this, it's really they're just loading the machine and unloading it. And so what we were able to do is go in and identify a solution, and that solution, really the best solution, was not to just place a robot in front of it. It was actually more cost effective to put a bulk feeder on the back, an automatic bulk feeder that would place the part into the machine, and then on the front of the machine we actually attached an extraction system to remove the parts from it. And it was extremely effective, and very, very cost effective overall.
So have you guys ever gone into a business and seen automated solutions like they've already got installed, but they've completely missed the point of implementing it?
Yeah. So, we'll go back to the very first question you asked me. What is automation, right? And a lot of times we get into what we'll call buzzword bingo. You've got this new fad that's come on and everybody wants to use it.
Right.
And that fad right now, and has been for a few years, is collaborative robots. Now, collaborative robots are designed to work side by side with a human. And they're fantastic, but they have their part to play.
Right.
And they don't play all parts. They only play their part. And what we see many, many, many times is a company will go out and buy these collaborative robots. They'll put these things in, and they'll hope that they can get this process done. And what we'll see is they'll run that process a few times, go back 6 months later, that collaborative robot is sitting there and it's gathering dust because it doesn't do what they thought it should do, right?
Oh, God.
It's much slower. It's not good for high volume processing.
Right.
So they struggle a little bit with that. So, we utilize robots. Our collaborative robots that we work with have 2 modes. They've got a collaborative mode and they've got a robotic mode. Now, the difference is we have to protect them. So if we're going to turn it into full robotic mode, we add safety sensors around. So that's how we handle it, to be able to make sure that, the application we put in is good and it's going to be what they can use in the future. So, yes, I think there's some mistakes that are made there. And then in addition to that, you'll see some automation systems that are put in to where if that automation system goes down, they have no way of running the piece of equipment or continuing on the process. So we have a lot of background in lean manufacturing, of course, coming from Toyota, and we make sure that we focus on, if we're putting a piece of equipment in, how do you back that piece of equipment up? How do you get that piece of equipment out of the way so you can continue to run, maybe not at the cycle time that you want, and maybe not in an automatic format, you have to have a person there, but you can continue to run. So that's something else that we focus on, and I think that's another mistake that I see in a lot of cases. They don't have that plan in case that automation goes down.
So when both of you go out onto a site, who is more of, Miles, are you more of training and maintenance, or Dotson, is that you?
He's more the engineering side, I'm more the maintenance side.
Okay. So when you approach training and maintenance after an installation, what are the first steps that you take to avoid, another automated machine sitting there collecting dust? Because I'm assuming at some point somebody's like, well, I don't know what to do with that.
That's right.
I think there's 2 aspects of your question. And the first aspect is when you're planning to put in automation, you really have to look at the value stream holistically. You need to understand what other processes are around it. And, here's a prime example. If a company has multiple CNC mills and they're staffed with one team member at each one of them, a lot of companies will go in and they'll put a robot to replace that person, and that person. And that's not the most cost-effective or efficient system. And instead, if they would look at it holistically and say, if we relocate this CNC mill over here and create a cell of 4 of those, and we can already tend those 4 machines with one team member and set that process up that way, then it's very easy to look at it and say, okay, now I'm going to put a robot or a cobot in there, and that it's going to tend those 4 machines overall. So that's the most effective method overall in there. And then the second phase of your question is after installation, right? How do you maintain the equipment? How do you make sure that it's going to be properly utilized and most effectively? And I'll let John talk to that.
Yeah, listen, so in the Toyota days, right, you get equipment from all over different places. Outside vendors would build the equipment, bring it in based upon specs. One of the things that was always hard was you never got good drawings. You really had some difficulties with having PMs set up, right? So we eventually got them, but it just took some time. So one of the things that I really pushed when we started this endeavor here at MiddleGround was I wanted to make sure that the equipment was designed to where it had a backup method. We had all of the drawings to hand over, whether it's mechanical, electrical, pneumatic, whatever it is, and we had PMs in place, and that we trained the organization that was going to take care of that piece of equipment before we ever installed that piece of equipment. So what we do now is once we build it in our shop here in Lexington, we will invite the people to come down from the company that are going to be maintaining this, and we will do a complete buy-off. We have a system and we go through and we check off for the number one, the safety, hitting all the E-stops and the things to make sure everything stops the way it's supposed to. And then we go into how it functions, how you recover. And if we have a robot that's associated with it, we will train them on how to recover from the robot. And then we set them up with the robot supplier so that they can have an opportunity to go to training on their own for the more detailed maintenance side of it. But we try to set them up so that they are successful going forward, because what we want to do is move on and do other additional solutions. If we don't set them up to be successful, then they're always calling us back, and then it slows our progress down as well.
So on that note, you've gone through, you've installed a new robotic solution or a cobot solution. You go through, you've pulled everybody in, you're like, this is how you operate everything. Here are the keys, you turn it over. So when they're actually going through, how do they go about measuring KPIs in general?
You take that one?
Yeah. So KPIs, the biggest KPI that we look for, right, is a return on investment. And the forging tending that we're currently doing is one that I'm pretty excited to see the KPI results from it, because they already have a visual management system in place that the forge is already uploading the information, the downtime of the forge. They're already capturing all of that information currently. And when we put the automation in, we're going to see the measurable results of the downtime decreasing and the throughput increasing overall. And we'll be able to really judge much better the ROI overall because we have real data coming in.
Yeah. Now, I would say, from a KPI standpoint, it depends on where we're at. So if we're looking at it from implementing the automation, so we control it as a project. So you're looking at, the design, the budgeting, the CapEx approval, all the way through ordering parts, building it up, and then doing the training and doing the implementation. So we have a system that we track all that through. But then when we get to the portfolio company, the KPIs we're looking for there is really uptime to make sure the equipment stays up and running. and then it's throughput, quality improvements, those types of things. And what we have typically found is that when you put an automated solution in place, your throughput will go up by at least 50%, at least.
50?
We have had automation solutions go in where you had 2 shifts of team members running for a certain demand. We've put the automated solution in, and they can run that automated solution 1 shift and achieve that demand, because an automated solution doesn't have to take a break. They don't go to lunch. They don't have an in-between shifts. They're consistent on what their output is. We as humans, we start to tire over the day, and we start to slow down slightly. So the automation solutions do not do that. So we get that huge KPI boost for just about any place we put an automated solution in place.
So going back to the original question in the beginning, what do I think of when I hear automation? I'm sure that there are a ton of workers out there who hear automation and they go, well, there goes my job. So when you all bring automated solutions into the building, what is your process for integrating the actual employees around to like calm them?
Yeah, absolutely. I mean, you know, it's really prime example, you know, of one that we implemented was the push rod former. And, you know, when we started looking at that project, you could see the consternation on the team members' faces. You know, hey, I've ran this job for 10 years. I'm really nervous that I'm going to be replaced with a robot. Absolutely understandable. But what we look at there is hey, there's already gaps in the manufacturing line elsewhere. And this is an opportunity that we can automate this process. That team member can then be relocated elsewhere on the manufacturing line, filling another gap that's over there. We know more gaps are coming in the manufacturing lines, and so that's one aspect of it is we're able to relocate those team members to other gaps in the manufacturing line. The second aspect, and John touched on this a little bit, is once we put the automation in, we're training those team members to maintain that equipment and teach the robot back to home and regaining master for it. And that's actually upskilling those team members. They're gaining skills that are usable in the workforce by doing that. So I mentioned the push rod former example, and I really appreciated this. You know, that we saw there was a team member in particular. He ran this job. He's really, really good at it. And he was nervous about the automation coming in. And when we put that automation in, and we replicated it 3 additional times, we followed up with his team member. He actually was now responsible for managing those 4 processes, maintaining those machines, maintaining that equipment. And he came up to us and he says, hey, before I was good, but now this is 1,000,000% better. And that's the aspect that I really enjoy about this role is being able to add value and improve those team members' positions.
Yeah, and that's saying something to qualify that team member saying that. This team member was so dedicated to manufacturing that part. He'd been on that same process for 11 years. He had a notebook, and for every part that he made, he recorded it in those notebooks. He had stacks of notebooks for 11 years. That's how much he cared about his job and about producing that part. And for him to be able to say that it's 1,000,000% better now is phenomenal, because you can see how connected he was to that process. Now he's that connected to making sure that equipment runs and maintains the production output. So it's phenomenal.
It's always exciting to see anybody, honestly, who's really passionate about something, whether they're talking about it, whether they're actually going through and they're living it on a daily basis. So that's always really inspirational. And if anybody's listening who's worried about their job, you've heard in the next 5 years, it's going to be, you're going to have a ton of jobs to apply for, apparently.
That's right. That's right.
So I do want to talk about an automation example that you guys have done, including like a solution, the challenges that you faced, and then also talking about the improvement in quality control, because I've seen some of the stuff that you guys have done, and it's remarkable. So
yeah. Well, I'll give you one that I know that we struggled with a little bit. So one of the plants, we had a team member. This is one that works really well with understanding how we find unsafe processes and we're able to automate around them. So we had a plant where the team member had to put the part into an induction heater. So they sat on a chair. They would pick the part out, put it inside of an induction heater. The induction heater would heat it up to around 1,800 degrees Fahrenheit. It's glowing red. And then they would put it into another container for cooling, right? And that's what they did. And it was an annealing process. And they did that so that they could machine it afterwards. So we go in, we see this, and we're going to go ahead and do one of our standard automation solutions, which, I've got to give Miles credit here. He sat down and we worked together, and he designed a dolly that you put the cobot on top of, and then we have a lot of other applications that we can put around it. And then it's, you can very quickly level it and go from one process to another. So it's really flexible. So we were going to use this solution for this application. Well, one of the things that we had to do was put the hopper on it. And we had to be able to put these parts down in the hopper. So you could put 200-300 parts in a hopper. It would feed it into a place where the robot could pick it up and use it. Well, we thought we had a great design, and we started testing it. And because these parts were tapered, they were jamming up, and we could not get these things to feed consistently. So it's not a solution that we wanted to put into the plant and let them fight with, right?
Right.
So we're trying to go through different cycles of problem solving. And one of our team members, Rodney Roark, we talked to him about it. And Rodney's one of these guys that he's like a dog with a bone, right? Once he gets it in his head, he's going to continue to bite on that bone until he figures something out.
Gotta love Rodney.
So I'm sitting at home one night, and he sends me a text message, and it's a video. And I look at that video, and I thought, oh, man, there's the answer to our problem. He figured it out. So he comes in the next day. We take a look at it. They go design it, and it's more of a stair-step process to feed the part not through the bottom but out the top. And this solution worked fantastic. And so we were able to quickly modify our design, go with that solution. And that robot is sitting up there today, and it's actually doing this process flawlessly. And we've taken a safety concern away of a team member potentially getting burned by holding onto those parts.
On that process as well, one thing, since you mentioned quality, one thing that's often overlooked was with that process, the way it was previously set up, if the operator ever forgot to push the pedal to cycle the induction heater, and they placed that part into the cooling rack, and it really wasn't heated up properly, it's going to go downstream, and it's going to be a hardened part going downstream to these other mills and lathes, et cetera, that's cutting on it, and you're going to tear those machines up downstream. So by us automating that process, the cycle doesn't proceed unless that part's heated up. The robot's automatically going to cycle that induction heater. The part's going to come out, get put onto the cooling rack, and proceed through.
Right. And I know you asked about quality. So because of our background and we understand how important quality is, we will do the assessment and understand what that flow out looks like from one process to another. And we will make sure that the solution has the ability to either select that part, check it for quality to make sure it's good, or we will take that part and put it in a spot where a team member has to physically check the quality, so that we don't build too many parts to where they flow out of the process. So we're always looking at that when we do these solutions and put that quality check in place.
Well, we're almost out of time, so I've got one more question. Let's see here. John, we'll start with you, and then we'll kick to you, Miles. How does the advancement of Industry 4.0 and AI complement automation? And are there key technologies your team utilizes as a result?
I can tell you that I think there's much, much more to come in the future, but even currently, it is very, very impactful. And I'll say that because I think there's a couple of areas. The advent of 3D vision and being able to control robotics with 3D vision has been phenomenal. We have it set up in our shop for bin picking. You can throw the parts down in any orientation you want. The 3D camera will take the snapshot of it, tell the robot where it's at, and it goes and picks it up. In order to do that, you would have to have thousands of points taught, and you would never get in front of it. We just can't put all of that into the manual robot programming to be able to handle all of the different variables that are sitting there. So that's one. The other one that has come on that's been great is being able to take a CAD file, run it through some computer systems, and it automatically programs the robot. Right. So now what I can do is I can take that to a company that doesn't have a lot of experience programming robots, and they may have a high variation of parts. Well, they can take their new part design, put it through the system, and then dump the program into the robot, and the robot will automatically go pick and place and do what we need it to do. So the advent of AI and things that we currently have in Industry 4.0 has been fantastic, but I think the future is going to be very bright for this stuff.
Miles, let me get your take on it.
Yeah, John touched on a large portion of what I've seen so far, and that's with the robot programming and creating the trajectory of the robot, that sort of thing. One that I'm pretty excited about is we're working with our portfolio company Stemmer to see if they can help us develop this solution. But when we have a 3D part in CAD model, being able to select certain edges or vertexes on that part is a little bit challenging to then be able to generate the robot path afterwards. And I think they've got some really neat technologies that can be utilized to allow the team member on the floor to very quickly potentially scan a 3D part and say, okay, I need to perform polishing on this surface, and they can quickly select that surface in the HMI panel, and the robot trajectory will be automatically created and the path created so that all the polishing lines overlap based upon the tooling that you have out there and create that surface texture that you're really looking for.
Man, it's been awesome having you guys on the show. Thanks for coming out.
Yeah, thanks for having us.
You guys are great. Well, I'm assuming that there's so much more to automation that we didn't even get to touch today.
Absolutely.
So yeah, I'd love to have you guys back on the show. And I think
Anytime.
I think after this episode comes out, there's probably going to be a lot of other people who have more questions. But I just want to say thank you all for joining us again for another episode of Executive Sessions, where we discuss trends and developments in the industrial manufacturing space. If you love our stuff, go to YouTube, go to LinkedIn, go wherever you listen to podcasts. We're everywhere. Tell us what you love. Tell us what you like. Subscribe, like. It really does help us out. But that will do it here for us today. Join us next time when we discuss all of that and more. And thank you guys very much for being here again. You guys are rock stars. And to the rest of the MGC Automation team, keep on rocking and rolling. Thank you all very much. This has been Clayton Gullett, and we'll see you on the next one.